Welcome to Internet TCI, our monthly program about the global Internet. My name is Rich Wiggins, and I'm speaking to you tonight from East Lansing, Michigan. I'd like to introduce my partner in crime, Charles Severance.
Thanks, Rich. This is our second show, and I think we're going to try to top the first show and make it an exciting show. We've got a number of different segments. Rich is going to talk about what is a URL in his Internet for Everyone segment. I'm going to go on the road in the Chuck and Rich on the Road segment to Livermore, California, and look at K-12 education over the Internet. We're going to do our Net News segment. The Internet interview is with Kevin Hughes of Enterprise Integration Technologies. And in the Tech Talk, I'm going to talk about the internals of the Internet and discuss what the difference between a connectionless and a connection-oriented Internet. So we'll try to keep it from being too boring. And of course, we always do Internet surfing. So Rich, what did you bring with you to the studio today?
Well, a little bit of show and tell here. I wanted to give people an idea that this isn't the only source of information about the Internet. I know that's shocking to some of our viewers, but there are other places.
It's the best source.
Well, obviously, it's the best source, but so far we're only monthly. And folks may want to plug into some of the magazines that are out there on the newsstands. One of them is New Media Magazine, which isn't primarily focused on the Internet, but it does have a lot of useful information, in particular about the World Wide Web from time to time. Another magazine that folks might want to check out is one called Internet World, and I'll give a warning to the viewer that this is a magazine that I've written for, and therefore they may want to look at it askance. But no, seriously, it's a pretty good magazine, and folks might want to check it out. There are some other more general magazines folks might find interesting. One of them is Online Access, and it has to do with not only Internet kinds of topics, but also sort of the bulletin board system community kinds of issues. Now, if folks are looking for ways to get connected to the Internet, that's one of the topics we'll be talking about quite a bit as we get going throughout the show. But you can also find in a lot of magazines diskettes that may act as sort of starter kits for one or more services that are out there. And in fact, one of the mass market information utilities, America Online, is especially aggressive about putting diskettes in their magazines. If you ever need spare floppies, you know, you buy the magazine and you've already got 4 or 5 of these AOL starter kits, you might as well grab another floppy. Finally, a magazine folks might want to check out is Wired Magazine. This is perhaps the most unusual magazine that talks about networking and politics and related issues. It comes out of California, and it sort of looks like it comes out of California. It's full of graphics, and it's hard to even find the table of contents and tell the ads from the editorial copy. But it's a good magazine, and a lot of folks are plugging into it. You've probably seen the IBM ad where they've got the nuns looking at Wired Magazine. So those are some of the resources folks might want to check into between episodes of the Internet show that we're putting on.
Well, speaking of useful information out there, I have this little tiny mini Chuck and Rich on the Road segment. What I did is I went out to Stanford University, and well, I'll just let the segment speak for itself. Take a look. Stanford the Quad, baby. What a place. What a place. Well, folks, here we are in the Stanford University bookstore. Many books. Many books. Many subjects. It's got 3 complete floors. It's got all the important books in the world, including... What? What's this book? The Internet for Everyone. Rich Wiggins. Let's take a look at this. See what's on page 410. What's on page 410? It's B. So, what'd you think of that?
Oh, that's really fine, Chuck. I'm glad to see that page has been included in every copy of the book, not only the one that I handed you after you wrote your chapter. That's very nice.
I had to check that, you know.
Now, do you usually stay in room 410 whenever you're on the road?
It's my lucky number. It's definitely my lucky number. Another important source of information in regards to this television show is our homepage, and the URL for the homepage is http://www.tci.east-lansing.mi.us/internet. Now, if you can't remember that long thing and you can't type it while I'm saying it, it's going to be in the credits of the show. But we hope to make this homepage useful. A couple things that we're going to do with it is we're going to have all the URLs of all the pages that we serve. So for example, you can take a look at the page, and down at the bottom we're going to have a page for each show. So here's the first show and the second show, and in the first and second show we will have various things. Another thing that we're going to do in here is for the third show, if you log in, you'll start seeing stuff for the third show even before the show comes on. And so for example, here you can see the segment for the next show. You know, introducing the homepage and the Stanford University Bookstore gag. So if you saw this in advance, you'd have known that there was going to be a Stanford University Bookstore gag.
I didn't see it in advance. I missed it.
Yep. Well, next time you better look at the show. So down here at the bottom is going to be all the things we're going to visit during the surfing segment, so you don't actually have to remember all the URLs and furiously write them down. Another thing that you can take a look at is all kinds of interesting stuff, like who runs the show, which TCI systems that are carrying the show. Right there, we have East Lansing, Michigan, Wednesday, 8 p.m., etc., etc., etc. We also have some behind-the-scenes photos of the show to keep it interesting. So there we are. There's you and me, Rich.
Well, we're right here.
There you go. There's Chuck and Vern fixing the computer. We always have to keep fixing the computer. There's our producers, John and Amy. And here's me and Amy smiling at each other. It's early in the show, so we're smiling. So, okay, so take a look at the home page. It's useful information. Save you from writing a lot of stuff down. You can even take a look at the scripts. Hey, send me email if you look at the script and don't like how I'm writing up one of my scripts. On End to Welcome here, talking about Internet Cafe. On the last show, we had a segment called Internet Cafe on the Road with Chuck and Rich. Well, it turns out there's a coffee shop right across the road here, 100 yards away from his. And we're going to investigate putting a computer in there and having our own Internet Cafe. So we look forward to next month and having our own Internet Cafe. You are going to run into URLs, or Uniform Resource Locators, everywhere you're going to go. You're going to see them in newspapers, you're going to see them on television, including this show quite a bit. You're going to see them on the network. Rich is going to give us an overview of exactly what is a URL, or Uniform Resource Locator.
Thanks, Chuck. As Chuck indicated, you are going to encounter uniform resource locators all over the place. Recently I was in Chicago at a blues bar, and I was trying to avoid anything to do with the internet. And this guy walks by with a t-shirt, and it's got a URL on the back of it. So everybody is on the World Wide Web, and everybody's trying to tell their story on the World Wide Web. So what the heck is a URL, and what do you do with it? That's what we're going to talk about in today's Internet for Everyone segment. Okay? An example of one of the companies that's prominently out there on the web is CBS TV, which has its homepage on the web. And you see a location of http://www.cbs.com. In fact, in their print advertising, they have that URL for folks. So people are probably wondering, what the heck is this URL thing? Another kind of a resource that we're going to talk about later when we go surfing is MSU's Interactive Weather Browser. And the URL for that gets a little bit more complicated, and we'll see what that looks like when we go forward later on in the show. Well, to understand URLs, first you have to understand a little bit about the computers that are actually serving information to you out over the internet. So we're going to talk for just a second here about the internet host names that people have to cope with when they're surfing the net. In the United States, if you're dealing with a host name on the net, usually you're going to find addresses like something.edu or something.com or something.net. So for instance, CBS might be www.cbs.com. That simply means it's a commercial organization. When you go overseas, you'll find that the last part of an address on an internet host name is a country code. It's 2 characters that are used to identify what country it might be. So you'll see .uk for United Kingdom, .au for Australia, and .ch for Switzerland, of all places. That's because of the name that the Swiss have chosen for themselves. We'll also see some addresses in the U.S. that end in .us, as we see overseas, especially places that have some sort of a geographic connotation. So this might be a school somewhere in Michigan, pioneer.washtenaw.k12.mi for the state of Michigan, .us. So those are the sorts of name conventions that you have on today's internet. When folks are surfing around the net, they're going to visit a lot of different kinds of places. We always call the internet a network of networks, and we truly have different kinds of domains across the net. So for instance, the main World Wide Web server at Michigan State is going to fit within the msu.edu domain, and it might be called www.msu.edu. Now, you may find in some cases you run across two kinds of addresses on the net. You run across the sort of friendlier form, which is a domain-style host name like jpl.nasa.gov, and folks will also run into another kind of an address called an IP address. Well, these domain-style names are friendly for the purposes of human beings, and IP addresses are friendly for the purposes of the network. In general, as a user, you don't have to worry too much about these IP addresses. It used to be that you did, but these days it's best to just concentrate on the friendlier domain names. Now, when you're using some sort of software to surf the World Wide Web, you'll be using something called a web browser. And that web browser might be sitting on your desktop at, let's say, jane.prodigy.com might be the name of your host name, your computer on the net. You can connect off to a wide variety of kinds of services on the net using a web browser. You can connect off to a World Wide Web server, and in this case that might be www.nando.net. You could connect off to a Gopher server, and the name might be gopher.msu.edu. Or you could connect off to an FTP server, and the address might be oak.oakland.edu, a nice archive at Oakland University. So this one class of tools called web browsers can get you to all kinds of different resources on the net. And the naming conventions for the host names give you a clue as to what kind of service you're connecting off to. So for instance, if we're connecting off to a World Wide Web server at an organization called Nando, which is the News and Observer in Raleigh, North Carolina, then we would have a URL that might look like this: http://www.nando.net. Well, this http://, as we'll see in a second, is shorthand for this is one of the highly graphical, nifty World Wide Web documents that's out there. So if we connect off to that address, we'll see the first page on their service, otherwise known as a home page, and it might look like this. Now, if we connect off to a Gopher server instead, we can use that same tool, whatever kind of web browser we might be using. It might be Netscape, it might be the Prodigy browser, it might be Mosaic, and we can connect off then to something like gopher.msu.edu. And here we'll have a Gopher menu. It's not quite as fancy as the sorts of home pages we see in the World Wide Web, but it can impart a great deal of useful information. We can even point our web browser at something like an FTP archive, which might be a good place on the internet to go get some useful software. So in this case, we're pointing off to the Oakland University FTP server. And now, using that same tool, using that same web browser, we can point and click and go into folders and fetch pieces of software and install them on our hard disk. So these URLs fall into a pattern. They begin first with some sort of a clue as to what kind of protocol it is. http:// stands for Hypertext Transfer Protocol, which is what you'll see for the fancy graphic web documents. If it begins with Gopher:// it's going to be a Gopher server, and as we've seen, FTP: begins web servers. Now, after the type of protocol, we'll have an address of a server somewhere on the internet, and that's simply one of those domain-style host names I was talking about earlier. Finally, you'll have an optional path to a specific document on that server, and this might be an example, /events.html. So some alphabet soup here we've been seeing. A URL is really a unique name or a handle, a way we can refer to or grab a specific document or resource that's out there somewhere on the internet. The word homepage, which we see a lot, is simply the beginning of a particular web document or collection of documents that's on a server somewhere on the web. And a web browser is one of these tools like Mosaic or Netscape that we're using to surf the World Wide Web. Well, why do all these web URLs begin with HTTP? Well, that stands for Hypertext Transfer Protocol, and that's the set of rules that govern how the documents will be moved across the internet off to your workstation for display by your browser. So it's Hypertext Transfer Protocol. Here's some examples of some typical URLs you'll run into, and you'll see quite a pattern here. You're looking for Disney's homepage, look at http://www.disney.com. They're all going to begin with http:// and then we could go to www.ibm.com, www.sony.net. We've seen the example of Nando. We can go to Michigan State's homepage, go to nasa.gov, and we can find the NASA homepage. So using this very simple URL naming scheme, we can certainly surf all around the World Wide Web and find a wide variety of resources. Our web browsers will also allow us to jump to a specific URL. They all have a way that we can point to a specific place, either by typing open URL or by going up to the current URL area and simply typing over the URL of the place we're currently visiting. And that concludes the discussion of what these URLs are all about and what we can do with uniform resource locators.
Rich, I think that was very interesting. I think the key that people ought to understand is that they're not really that hard. They look sort of like gobbledygook at the beginning, but there's a pattern to them, and it's pretty simple. I think that these URLs are one of the coolest things that the web has done, and that is to create sort of a mailbox for data. This is a fixed thing. It says, go here and you'll get data. I mean, I'm beginning to guess URLs. www.fedex.com. Someone said, Federal Express has a web page, and I immediately just guessed what it was, www.fedex.com.
Yep, and in fact I did the same thing when I discovered the IBM homepage long before it had ever been announced, using the same strategy. And it is a unique, useful handle for going and grabbing something. You get it in an email message, and if you know how to cut and paste, you can paste it into your web browser and poof, you're off. On every episode of Internet TCI, we're going to have a segment called Chuck and Rich on the Road. I personally have a bit of a problem with that because, in my opinion, it ought to be called Rich and Chuck on the Road. But somehow I lost that battle. And also it's the case that Chuck's a little bit ahead of me right now in terms of the segments that are in the can. He's been on the road more than I have, and he's got some good stuff on High 8. So the first few episodes of this segment will be Chuck on the Road. And fortunately, I'm catching up. I was just down in Durham, North Carolina, and really I think got some good stuff about a place called the Raleigh News and Observer. While I was down there, I had the opportunity to visit a cultural fixture in the area, which is the Durham Bulls. And I thought, while I was there, you know, we ought to institute a new tradition for Chuck and Rich on the Road, and that is whoever's on the road ought to bring back something nice for the other guy.
That's a good idea.
So while I was at the Bulls game, I figured I'd get Chuck an official Durham Bulls baseball.
Oh, man.
So
That's pretty neat. Let me see that.
well, here you go.
You know, I've never seen a Durham Bulls game, but I did see the Durham Bulls movie. Was it like anything like that?
Well, I don't know. I was like Kevin Costner, but I didn't see Susan Sarandon.
Okay, well, Rich, I look forward to your first segment of Rich and Chuck on the Road. My segment of Chuck and Rich on the Road, I went out and I visited Brian Lindow of Lawrence Livermore Laboratories. Brian is the director for the National Education Supercomputer Program. And this program works with about 10,000 students in K-12 schools. And what they do is they use supercomputers to explore certain scientific things, from climate to bridge building to various other things. And it's really exciting because it makes heavy use of the internet. What the students do is they copy software down to their computers over the internet, whether they're Macintoshes or MS-DOS computers. Then they create the simulation using very easy-to-use tools that have been developed by Brian's group. And then what they do is they FTP up what effectively is a batched computer job, very simple. They FTP it up to the National Education Supercomputer computers at Lawrence Livermore Laboratories. The computers grind on these jobs and send back little movies to the students, and the students can then see the movies. It's very exciting. My research area is in high-performance computing, and I've always wondered how you can get kids to be able to use high-performance computers. And I think Brian has done an excellent job on this, and I'm very excited about what he's done.
Supercomputer program is open to all K-12 teachers and students, and really the general population. We have a Cray supercomputer that is dedicated to education that anyone's allowed to use. And you can use it at no cost to you. The software to access the machine is free and public domain. And your connection or getting to the supercomputer can be done through the internet or through an 800 number and your modem, so at no cost to you. One of the ways we use the web is to advertise the use of the supercomputer. Our homepage is accessible to people on the internet, and a lot of people just find out about us by just stumbling upon our homepage. They also can use the web to download the software, all the public domain software, download examples of how other teachers and kids have used it, along with curriculum that the teachers can pick up and use in their classrooms. They also use the web to move the files from their microcomputer, being a Macintosh or a PC, to the Cray and back. So we use it extensively, and we'll continue to use it more and more. They can also, while on the web, check out and look at the current status of the Cray and how busy the Cray is, because of course we're sharing this machine with about 10,000 teachers and students all across the country. So there's 10,000 of us sharing it right now. The applications you can run, or what do you do with the supercomputer, or what do schools do with the supercomputer, is they can run simulations that are based on the supercomputer that really only supercomputers are really good at doing. One of those applications is ray tracing, another which is a computer graphics technique used to make realistic looking pictures. Another application that you can run is climate modeling. In other words, you can change characteristics of the Earth. A good example is to wipe out the rainforest, run a climate simulation on the supercomputer, and it will make predictions as to how the Earth's climate will change. Another application is a fractal application, which allows you to generate fractal images using different techniques in mathematics. The fractals can be used to grow trees and plants, and you can explore how trees and plants grow and replicate themselves. Working on a molecular modeler that allows you to design your own molecules, and the Cray will analyze your molecules. And finally, a bridge building simulator where you can design a bridge, and a force will be put on your bridge, and your bridge will smash or be fractured, and you can see where the bridge is fractured, and then you can go back and redesign your bridge, just like structural engineers do, and how they use supercomputers, because they design those bridges before they actually build them. Well, these things are what scientists do all the time, and we want to give that kind of access to kids, to show kids what scientists do and get used to some of the techniques that scientists use, and get them excited about the science and the mathematics behind the science. This is the climate modeling application. On the application, the student can change a lot of the characteristics of the Earth, including the orbital characteristics and so on. But one of the fun parts to do is to come to the map and to redraw the Earth. In other words, draw in the new surfaces of the Earth, move the mountains around, move the forest around, get rid of forest, add new land masses, so on. They also can adjust ozone layers, allows them to make ozone holes. They also can adjust the sea surface temperatures, which allows them to do El Nino experiments. Can really redesign and make a completely new Earth if they choose to. After they make those changes, they would save them and then send those changes to the Cray, where we run the climate simulation. And that climate simulation may take up to an hour or so to run on the Cray, and what they will get back is a series of animations. Those animations will show the results of their run. This is using the same climate model on the Crays as our scientists use here at the laboratory. We just have an easier way of using it, and making more changes with many more people running the model every day. Because again, we have a dedicated Cray to run the model on. So the teachers do many different types of experiments with the students with the model, between the deforestation to they redesign the continents to the Pangea continent, and to look at the model or look at the Earth's climate, what it was back then. Also doing lots of different experiments, from the melting of the polar ice caps to El Nino again, to different types of experiments to see what will happen. A lot of times kids will do things of deforestation, which may increase rainfall in other continents, and which may be good for that continent. So they may want that to happen, but again, these are climate models, which means we're not sure of the accuracy. They're just tools to help us guess at what would happen, just as a scientist. And so they argue in their classrooms whether you believe the tool or not, and those usually leads into very good discussions as to what should we do about it, because then it weaves in on what kind of laws should we set to try to curb whatever they're testing. Where is the internet going to be in 10 years? certainly as a commercialized venture, it will not, I don't think, be based on in the government at all. It'll be a total commercialized venture, and the government will be one of the users of the network. Hopefully we'll see it in everyone's house, just like cable television. I think it was very similar that cable television has really caught on, and almost everyone is getting cable television. And it will be very similar in that type of service, in that you will be able to get a type of programming, but then you're also able to publish. You're also able to have your own TV station and be able to advertise whatever you want to the rest of the world. And I think the biggest benefit is going to hopefully be to schools, because they'll get access to all this information very quickly, and access to other teaching techniques, to other teachers, so we can take the people who are the best at it and make them accessible to everyone, whatever that field happens to be.
Well, Rich, what'd you think of that?
I thought it was great. So much of what is out there in the way of purported educational software is really nothing more than electronic page turning, or sort of an animated bad ripoff of Barney. And this is where students can actually interact with live data out there on the net and see some real results. I was especially impressed with this point about they're manipulating the same information with the same models that real scientists are using, and I thought it was really neat.
Right, the only thing they really did is made the model, like the climate model, a little more coarse so that it ran a little more quickly. But I think it's a neat trend. It's actually a positive use of the internet. I'm pretty excited about it. What I'm going to try to do is set up a joint program between Michigan State University and Lawrence Livermore Labs to actually teach the students in our K through 12 schools how to use this technology over the internet. This is a full-page ad in the May issue of the People magazine telling people about Dave Letterman moving his show to London for a week. A URL, or Uniform Resource Locator, is featured prominently in the ad. The URL for CBS is http://www.cbs.com. The concept of a URL is a very recent invention, as Rich talked about in his Internet for Everyone segment today. Before a URL, to retrieve information across the network, people need a couple different kind of things. They need a type of software or protocol to use, the host to connect to get to the information, the name of the information on the host, and some format about what the information is stored in. Now with the URL, all these pieces of information are either contained in the URL or automatically figured out by your client software. So now the URL, http://www.cbs.com, is an absolute address to a piece of useful data. This makes it very attractive to people to include this URL in other forms of advertising. I would also observe that David Letterman information was up on the net long before the CBS World Wide Web page. There's a network news group called alt.fan.letterman, and there's been a fan club mailing list for some time. The person who maintains these lists is named Sue Trowbridge, and she actually has the top 10 list out right on time. I think she must type it as she watches the show. In this, Frank asks Ernest, is television part of the information superhighway? And Ernest answers, only as a rest stop. As I look at this cartoon, it tells me that the cartoonist, Bob Thaves, has a good idea of exactly what's on the internet. In this simple cartoon, he has captured the difference between the internet and television and the information superhighway. The information superhighway will be a superset of the media forms that we use today. Television will be one of the forms of media on the information superhighway, and as the cartoon says, it will be the rest stop. When you want to relax and be entertained, television will still be the media for you. Bob also puts his email address in the cartoon. It's fnebobt@aol.com. Perhaps someday he'll put up some of his cartoons on the web. A number of cartoon sites are currently up on the web. One of the earliest cartoonists on the web was a cartoon called Dr. Fun, which is produced by a fellow named Dave Farley, who works at the University of Chicago Library, and he does Dr. Fun in his spare time. Here's another internet-related cartoon. This cartoon draws its humor from an important internet issue. In this cartoon, Paige's brother has posted Paige's phone number to the internet, probably to a news group. Now Paige is getting calls from around the world. The brother calls the internet the ultimate bathroom wall. Once you're connected to the internet, you can send data anywhere in the world also connected to the internet. Network news groups literally broadcast to all corners of the earth. This broad communication capability can be used in very positive ways or not so positive ways as depicted in this cartoon. While this ability to broadcast information often scares people when they initially come onto the internet, it turns out not to be a problem in most cases. I get far less junk mail across the internet than I get through my mailbox, and I see far less offensive material surfing the net than I do on my television channels. Now, I'm not intending to say that there's not offensive material on the internet. There's plenty of offensive material. My point is, unless you go looking for it, it tends not to come looking for you. There are several reasons for this. The biggest reason is that the internet is actually a community with its own set of values and rules. While it's possible to come onto the net and act like a jerk by broadcasting offensive information that the net finds offensive, or actually more likely pointless, the existing folks on the net will make sure that you do not feel at home in a number of ways. This self-policing aspect of the network community is actually a very interesting phenomenon. Another reason that people tend to behave on the net is that most of the information you received is marked as to where it comes from. This is sort of a caller ID system. If you get some junk mail, you can very easily send a message politely requesting that you don't want it anymore. And if the polite approach doesn't work, you can write a program to send a message every 5 seconds to the person sending the mail. While it's possible to send information anonymously, it's rather difficult to cover your tracks. In this article, free software can hang up phone taps. In this article, free software to hang up phone taps, the author claims, program on the internet turns computers into untappable telephones. This is a wire story through the Associated Press. The article goes on to talk about all the problems this causes. This article falls into a category I call sensationalist internet reporting. Some news reporters are tapped into the internet and have a good sense of balance about what's going on the internet. These reporters often write good stories showing both the good and bad about the internet. Other reporters use the internet to write an exciting story. They take some basic, simple issue and write a story as it were extremely new, some exciting development, and they're the ones that are breaking this story. It seems that sometimes if you shout even something simple loudly enough, you get attention. For example, one such story might be, people use fax machines, and another, in our series of investigative journalism, we explore the impact the fax machine has made on the decline of family values, ... As a matter of fact, my wife and I were discussing this particular article, and she suggested a new segment on the show called Internet Tabloid, where we report something really sensational about the internet and ham it up.
Thanks, Chuck. As we saw in those examples that Chuck pointed out, a number of newspapers are telling us their view of the internet from whatever perspective a particular reporter might have. We're seeing some major feature articles as well. Here's an example from the Chicago Tribune where they're telling us what it is to explore planet internet. Well, it's the case that newspapers are not only telling their idea of the story of the net, they're plugging into the net as a form of publishing. USA Today has a homepage up on the World Wide Web, and they're also acting as an internet access provider. So we're not only hearing the news and reading it through the media is becoming a form of internet service provider. In other news of the net this month, one item that's of importance to us is that TCI Cable has announced a new service that they've called At Home. At Home will be an internet service available on TCI systems throughout the country. This effort on the part of TCI is headed by William Randolph Hearst III, and it's the case that they have not yet chosen a nationwide vendor for cable modems. They're working on that. Now, trial programs such as we have in East Lansing, in mid-Michigan area, will continue. USA Today estimates that we're going to see this as a multi-billion-dollar business by the year 2000. It's been announced that the Microsoft network is going to carry NBC News footage and other information from NBC available on demand. What this means is that folks will be able to use a browser of some sort to go and pick the articles they want and perhaps get audio and video on demand. What's interesting about this is that NBC is really spurning its own corporate sibling of Genie and going with a different information utility. They've also left, in so doing, the utilities Prodigy and America Online. Significantly, NBC will remain on the World Wide Web, so you don't have to be on Microsoft's network in order to plug into this service. Bill Gates was quoted as saying, "I'm a big believer that the interactive world can be very complementary with the broadcast world." We've had a number of instances of politicians getting into the business of worrying about decency on the net, and Senator Exxon has proposed that we should outlaw certain materials that he considers to be indecent. A number of civil libertarians are naturally somewhat upset about this. Under the rules that Exxon proposes, all network service providers would be responsible for all of the content that they carry, and that has ominous implications for those who have those responsibilities of managing networks. Organizations such as the Electronic Frontier Foundation and the Freedom Forum First Amendment Center are opposed to Exxon's amendment. There are companies that are springing up as a result of this set of concerns. They're trying to offer solutions to the decency problem. For instance, a company called Surfwatch Software has a product that allows blocking of particular materials on the net that some parents might find offensive. There are others that are working on marketing similar tools and services, according to an article in the Wall Street Journal. We hear a lot about folks that are trying to make money on the internet, and the question arises, is anyone actually making any money in so doing? According to an article in Investor's Business Daily, Netscape Communications Corporation is a startup that is in fact making money with their products and services. However, they report it's questionable among other large internet companies whether they're actually breaking even. It's the case that among those companies that are dedicating themselves to internet services, about 70% are in fact internet access providers, not vendors of tools. One tool that's got a lot of people's attention is a tool from Sun Microsystems called their Hot Java enhancements to the World Wide Web. These extensions will allow us to have features that are much more dynamic and moving on screen. We'll have features such as ticker tapes, moving logos, slideshows, and so forth. Netscape Communications has announced that they're going to license this technology. And Sun Corporation's Chief Technical Officer tells us this is the difference between black and white and color TV. So watch out, the web's going to get a lot more exciting. Cable TV's Discovery Channel has decided that instead of splitting apart into a number of subset channels, they're going to use the internet as a way to offer more specific information to narrower audiences. They're going to have topics specifically on science, history, animals, and living. And they expect to have this web service up by July, according to an article in Broadcast and Cable magazine. So that's tonight's news on the internet. This episode's internet interview, Chuck interviews someone named Kevin Hughes at Enterprise Integration Technologies. As you'll see in the interview, this is a remarkable young man. I found him interesting enough that I profiled him in my book as a pioneering World Wide Web information provider. Chuck, why don't you tell us about the interview?
Well, Kevin got started on the World Wide Web at Honolulu Community College, and what happened is he became a system administrator, and what he did is he looked for ways on the internet to use the internet for distance learning, and he came across the World Wide Web, and as he puts it in his own words, he said he went nuts, and he created the first hypermedia, multimedia, campus-wide information system with graphics and movies and MPEG sounds. And this was sort of at a time when the web was just getting exciting, and a lot of people looked to this site to see what it was possible to be done on the web. And what happened is, in part because of his fancy, his real nice job on the web, he was offered a job. They sort of came right to him at Honolulu Community College and said, hey, would you like to work for a small startup company in Silicon Valley? And he said yes, and the rest is history. Now, working at EIT, he's done things like the Internet Shopping Network, worked on CommerceNet, a program called Focus Hope, and the web pages for the Jones Educations Network. I caught up with Kevin after he'd spoken at the Web World 95 conference in Santa Clara, California, and Kevin talked about how the web got started and what he thought the web might evolve to in the future.
Tim Berners-Lee, who really created the web, he said it was the propeller heads that really started things and made things happen. It was these propeller heads and the general internet community, which for many years previously had lived in the internet as if it was their own home. They had their own community, their own jargon. They knew how to relate to things online. And so when they heard about the web and saw the web, they said, wow, I can make whole new communities with this. I can really talk to people with this. It really wasn't until there were concrete examples of the kind of things you could do which made it more appealing previously you might just see a screen of text and you would say, so what? Any computer could do that. But once you saw a graphic and you said, oh, by the way, this page with these nice graphics in it came from someone in Australia, you would say, wow, really? That's neat. Let me try to do that. So you started to have all of these educators and administrators just trying out stuff and being, you know, the regular propeller heads that they are, that we all are. And the growth of the web is due to the whiz-bang factor. It looks trendy, it looks sexy, and there's really not so much more that you can do with it that you couldn't do better using other traditional media. What really attracted people to the web and has made it grow is the fact that you can make stuff and send other people stuff. And everyone's saying, hey, look at my stuff. That's what it was all about for a long time, and that's what it's going to be about for quite a while. I think a lot of people are just starting to get wind of the fact that the web can be a serious advertising channel, and we're just seeing a lot of larger firms which have done quality work in television and other mediums start to do the same quality work on the web. I think a lot of people these days like to quote Marshall McLuhan. He's the guy to quote. Everyone seems to do it, so I will put in my nifty little quote. He said a wonderful thing, which is that all new media encapsulates the previous media before it. When you think of the book, it can encapsulate speech. You think of the TV, it can encapsulate print media and photography and film. And you look at the web and you say, really, I can represent TV in a way, I can represent print media, I can represent photography, and the things that are coming next will encapsulate all of these things. And it's going to be a completely new, different kind of space that people can do just about anything we can imagine in this day and age. VRML, well, it builds upon the idea of virtual reality. If you've heard of virtual reality, one can think of it as simulation technology which, in a way, is represented in three-dimensional form using computer graphics. VRML hopes to do for 3D what HTML has done on the web. It's meant to be a language through which people can create three-dimensional worlds and structures and new ways of interfacing with people and programs in order to get things done.
Have you seen any prototypes of that?
Yes.
Wow, so you're sort of like in a room, and they put a box, and they put a person.
You can easily imagine in easily 5 to 10 years' time, sitting down in what looks like a virtual restaurant and chatting around a table with your friends. And you might pick up a napkin and scribble some notes and show him and say, oh, look at this idea, what do you think of this? And he'll take a look at it and say, I like that, let me just save it in my little scrapbook. And he'll grab it and save it on his computer, wherever he might be located. And I could be lounging on a beach for all I know. And you can enable these kind of collaborative environments. Certainly, if reality is virtual, not only can you make places and interfaces that look and act like the real thing, things that you don't really need any specialized training to do, and on the other hand, you can make incredibly fantastic worlds. You can create magic, in effect.
Do you think you'll have a television and a computer at home, or just a television, or just a computer?
What kind of question is that? You're assuming I'll have something I think of as a television and something I think of as a computer.
True. What will you have it? What will you be in your house in 10 years?
Well, 10 years, I suppose that's a little easier to visualize. I think I'll have one box. It'll certainly be one box, or one device. I'm not sure exactly what it'll look like, but it'll certainly give me a lot of what I want when I'm sitting back in bed and I don't want to have to think, or when I'm thinking and I want to let everyone else know what I'm thinking. It'll do both of those things probably fairly well, and it's something I could fit in my backpack and carry around.
Thanks, Chuck. That was really a useful and informative interview, I think, with Kevin. Somebody like Kevin, I think, is really a person for these times. We don't have many critters like that. Fortunately, we have a few of them at Michigan State that are working with us on some web development. But what I like about somebody like Kevin Hughes is he smoked the big guys. It wasn't the MIT Media Lab that did the first really cool tour of a campus. It was Honolulu Community College and Kevin Hughes.
Right, that's pretty neat. Kevin, one thing Kevin mentions that I want to sort of amplify, he talked about a community and how the people in the internet had developed a community. That's one of the neat things about the internet, where you can develop a set of people that you know that are close to you, that you might have some very focused common interests, like a particular kind of woodworking, and develop your own community and have meetings and get to know people all across the world. And that's one of the things the internet allows you to do, is to get to know people with very similar interests and create your own little community on the network.
In every Internet TCI episode, we're going to try to have a Tech Talk segment, and we promise we'll keep it reasonably brief and we'll try to keep it entertaining. So Chuck, what's in tonight's Tech Talk segment?
Well, Rich, tonight I'm going to talk a little bit about some underlying philosophies of networking. There are basically two types of networks: connection-oriented networks and connectionless networks. The connection-oriented networks have, in general, simple user devices that connect up to the network, and the actual network itself is responsible for reliability. And the way it works is you actually make a connection, then you send your data across the connection, and then you hang up the connection. Now, the prototypical example of a connection-oriented network is the telephone network. Okay? You never have to retransmit the things you say over the telephone. Somehow or another, it makes it to the other end. Another example that people may not know about is a network called X25 Public Data Networks. GTE SprintNet is an example of that. And one of the primary things that's done on the GTE SprintNet is credit card authorizations. Do you ever wonder what's hooked up to those little credit card machines when you walk into the gas station? Well, it's actually hooked up to a highly reliable, connection-oriented public data network that zips your card, sends it across to a computer, and then authorizes your card. In contrast, a connectionless network, the user devices that then connect to the network are a little more complicated, like a personal computer rather than a telephone. The devices are actually responsible for the reliability. The network is not responsible for the reliability. Each piece of data is sent in what's called a packet. Each packet has the complete address of where things are going, both the source where it's coming from and the destination where it's going to. And the classic connectionless network is our TCP/IP network that we use on the internet. So, in either case, you sort of treat the network as a black box. You know, have a connection, one person sends some data, the other person receives the data, and there's this kind of amorphous glob we call the network. But in actuality, the network is made up of a bunch of different components, and they're connected. And a backhoe can dig up one of the lines and ruin one of the lines. So I'll start out by sort of tracing a packet through a connection-oriented network. So we have the person on your left who's going to want to say the word, think the word hello, making a telephone call. And so the word hello moves through the network, and each one actually lets go of it and passes it on to the next thing in the network. And there's reliability along each of these links back and forth. And then the data moves, and eventually the data is delivered to the final user of the data. Now, let's say, for example, there was a problem halfway through, and I've indicated this by the little red link. So this particular link is either loaded or has some problem. The network is responsible for the reliability. This particular link, we can't use it. Maybe a backhoe dug it up over last night. So now the network will actually simply reroute the data and move it across a different path and actually deliver it to the end user. Now, this has a lot of advantages. When you have a simple connection to the network, this works very well. But unfortunately, it has the disadvantage that inside each of these connections, they actually have to store the data until it's known to be reliably delivered to the other end. So you actually need to have a great deal of storage inside of each one of these things. Now, if I contrast this with a connectionless network, now we have a computer. We are talking two computers. One person on the left is going to say the word hello to the person on the right. The difference is you'll notice that the hello is going to actually stay in the source computer. We have the same outage. So the hello goes into the network and begins to be forwarded. But now you'll notice that it's stored in the originating computer. Now, at this point in the connectionless network, the network actually is no longer responsible for the absolute reliability of the data. So it encounters a downlink. So what it does? It just throws away the data. It says, can't deliver it. The network actually internally reconfigures and comes up with new routes from the source to the destination. After maybe a second or two, the source computer decides, I think I'll send that piece of data again. And each piece of data or packet has its own address, so it knows how to deliver it. So now the data is sent, and because the routing has been updated, a different path is going to be taken through the network. And now it's going to be delivered. And now the data has actually been delivered to the destination. Now the destination sends a message back and says, hey, I got it. So the source can actually discard the information. Okay? Now, this way the network does not have to actually store the information over long periods of time. It makes it simpler and more effective. So, to recap, a connection-oriented network is best when you have simple user devices. The network becomes responsible for the overall reliability. The devices are not. Think about the little devices that are at your gas station when you're zipping your credit card. They do not have a bunch of storage in them. They send the data and they assume that the data makes it. Now we know they don't always make it, but it either makes it or it doesn't make it, and they don't worry too much about retransmitting. On the other hand, a connectionless network has complex user devices, storage space in each of the devices, and the devices are responsible for the reliability. The network may or may not work. The network has the right to throw any piece of data away anytime it feels like it for whatever reason. It might be load, it might be various other things. So in the internet, this connectionless approach is really essential, because if we're sharing network bandwidth with all these other different organizations, Michigan State University uses bandwidth from TCI, and TCI uses Michigan State's, and all these other networks, and we use Berkeley, California's network. With this connectionless approach, we actually can share the bandwidth because we always have the right to throw away the data. Okay? So I'll move your data as long as it's not too much of a problem for me. And if it's too much of a problem, I'll throw your data away, and I can send it some other way. So the key is the connectionless network. We don't require network reliability. Now, of course, the internet is very reliable, but it's not required to be reliable. On the other hand, a connection-oriented approach is very good when the network is owned by a single organization, and there's actually data that you don't want to get lost. So in this tech talk, I sort of wanted to summarize a little bit of those two important issues, and I think that connectionless stuff is really one of the reasons the internet is successful with the multiple organizations.
Thanks, Chuck. That's a useful summary. Did you realize that those little devices that they have at the gas station you were referring to are responsible for a lot of the fraud among credit cards?
I didn't know that.
Yeah, because you look at the screen and it says, please swipe card.
Oh. Ooh. And he's a comedian, too.
What can you say?
Yeah.
Thanks for that informative tech talk. Well, we've done a lot of yakking tonight, and now it's time to do a little bit of surfing. Let's see what's out there on the World Wide Web. Before we get going on that, though, I do want to make a plea to our viewers. We would like to hear from you. What are your favorite sites on the World Wide Web? And besides that, we'd like to know what questions do you have about the internet and internet technologies. So please take down the email address you see at the end of the show and send us your questions and send us your favorite websites. Now, the first site that we're going to visit is an interactive weather browser that exists at Michigan State University, and in fact it was put together by a young man named Charles Henrich, who happens to work for Mr. Severance. So let's see what it looks like.
Okay, Rich, what we got here is we've got the current conditions as of the show, and Hurricane Allison has just gone through, and it's going through the southeastern part of the country. So what I can do here is I can click on any of these little white numbers, which are the current temperatures, and what we'll see is we'll see the current conditions at that particular spot. And here we have Macon, Lewis, Georgia at about midnight, or actually about 11 o'clock, and it's 71 degrees, 93% humidity, barometer's falling, and the winds are gusting to 24 miles per hour. So
not surprisingly, with Hurricane Allison just going through, they still have some gusting winds.
Right. So let's go to the next one, Virtual Tourist.
Okay. Now this is a site where somebody at the University of Buffalo decided a while ago, you know, we ought to have a different kind of an interface to the web where you don't just have to follow menus. We should have a map so you can go cruising around and find places by geography. So we're going to go to...
I'm going to click on North America.
Okay.
And I'll click on the United States of America.
Let's head for California.
Head for California. There's a lot in California. Now I will click on California.
What the heck?
Ooh, llnl.gov. I just saw the URL go by. Guess where that's at?
It must be Los Alamos? Lawrence Livermore. Aha.
Ah. So where do you want to go? Bay
Let's
Area?
go to the Bay Area and let's see if we can find somebody we know.
Oh, I bet we'll find EIT pretty easily.
Wow. Now, we can't actually zoom in and see Kevin Hughes in his cubicle running his web server. It doesn't quite go to that level of detail. Eventually, we do run into a menu. But this sort of gives you an idea of the geographic reach of the web and how there are ways to navigate it truly geographically.
Now let's go to Jones Computer Network next.
Okay. Now, these folks are the people that put on a show called, or a series of shows that make up the Mind Extension University, and they have a number of other programs on cable TV. You may see them on your local system.
Want to take a look at Mind Extension University?
Sure.
College,
Go ahead.
college credit courses to your home or business. Several college degree programs are available. ...
A lot of universities are getting into what they like to call distance learning, but this is an example of a university that's exclusively available over cable and now over the World Wide Web.
Let's go to the White House. We haven't visited the White House yet. We ought to eventually get there.
Okay.
So tell us a little bit about this page, Rich.
Well, the White House homepage is one of the most popular pages out on the web, and I happen to know the folks that run the service, and they've put a fair amount of effort into making it look pretty. They actually hired a graphical designer to set up some of the information that's out there. Oh, the lovely What's New, yes?
Just trying to see if I could find your stuff in the What's New.
Well, if you go down far enough, you'll find a pointer back to Michigan State. They're constantly adding stuff, so...
Okay, well, we'll go back. Let's cruise on down a little bit. You talked a little bit about newspapers. Why don't you talk about that?
Okay. A number of newspapers are establishing presences of one form or another on the World Wide Web. In future episodes, I want to talk a lot about the News and Observer because they're doing really more than just having a presence out there on the web. They are, in fact, a major internet access provider in the Raleigh area. In fact, for $29, you can subscribe to the daily and Sunday paper and get internet access for one flat fee. So it's kind of an interesting way that they've moved into things in a big way. Where are we?
We're at the Durham Bowl. We're at the Durham Bowl.
Heading for the Durham Bowl.
Thanks for the baseball. Well, I guess we're about out of time, so we better wrap things up, Rich.
Well, you're quite welcome for the baseball, Chuck. And I'm sorry we're out of time. We're going to have to spend some more time surfing in the next episode. In order to do that, we need to know where to surf. So you folks out there, send us some email and tell us your favorite sites and send us your questions. We'll see you next time.
Well, we hope you enjoyed the show, and we'll see you next month.